All right, in the next section here, we're going to talk about segment relationships within circles. So we're going to talk about how to find missing lengths of segments that we see within circles. So whether it's secants, tangents, or things like that, how do we find the different lengths given by a problem here? So the first thing we're going to look at is when the two lines intersect inside. So when we intersect on the interior or inside of a circle, each chord is divided into two segments. So notice I have this chord AB, but as soon as it hits chord DC, it gets split into chord BE, and it gets split into chord AE. So I get two different segments for that chord. Now what ends up happening here is when this type of situation occurs, when I have one chord hitting another, then I can take each piece of the chord. So I can take EA, multiply it by the other segment, BE, so that's where I'm getting that EA times EB, and set it equal to the product of the other two pieces. So EC times ED. So when we're looking at this, this is kind of what we're looking at here. I can separate it into two separate pieces. So the two pieces of this chord multiply to be the same as the two pieces of this chord. And so if we look at an example here, I have my two chords, so I've got JK intersecting with ML. So I'm going to take the pieces of JK, and so the two pieces are X times the other piece X plus 4, and I'm going to set that equal to, I'm going to do the other two pieces, which is X plus 2 times X plus 1. So when we see this, this is where we kind of have to use our distribution technique again, and this was something we saw a couple sections ago. So if I'm looking at the first part here, I take X times X and get X squared. I take X times 4 and get 4X. And then on the other side, as I distribute, so I'm going to start with the X and I'm going to distribute. So X times X is X squared. Then I'm going to take X times 1 and get X. Then I go with the 2 and I distribute it. So 2 times X is 2X. 2 times 1 is 2. And so now what I can do is I can go ahead and combine like terms. So as I look at this, notice how there's an X squared on either side of the equation. So right away, I'm going to go ahead and cross those out. So the X squareds are going to cancel each other out. I don't need to worry about those at all. That means on the left side, I have 4X. On the right side, X plus 2X becomes 3X. And then I just have my plus 2 at the end. And so now if I subtract 3X from both sides, I get X is equal to 2, which is not my answer. That is the first step in my answer, but I need to find ML and JK. And so for ML, if I plug 2 back in, on this first part, 2 plus 2 would be 4. On the bottom part, 2 plus 1 would be 3. And so ML would have a total length of 7. On the other side of that then, if I plug in 2 for X here, I get 2. And if I plug in 2 for X here, I get 6. And so JK would have a length of 8. So on these types of questions, don't just stop at X necessarily. Make sure you pay attention and decide whether you need to go further and plug it back in. But that's all we're going to do on this type of question. One piece times the other equals one piece times the other. So you just got to stick with each chord and multiply the two pieces together. Now, when we work with secant lines, so secant lines, if you remember, were lines that intersect the circle twice. So like E to B would be one secant, and then E to D would be a second secant. And so what happens is when these two secants come together and meet on the outside, the segments formed are relatable through a specific relationship here. So two secant segments share an endpoint outside the circle. Then the product, this is multiply. The product of the outside and the whole segment, that's going to be the two pieces that I want you to really focus on here, is the outside and the whole segment for each secant is equal. So what they're saying here is if we look at this picture, EA is the outside portion of that first secant line, and then they're multiplying it by the entire length from E to B. So it's the outside times the whole thing, and then they do the same thing on the other side. E to C is the outside portion, and then we multiply it by the entire length, which is from E to D in this particular picture. Now, what I want you to remember on something like this is basically you're always going to take the outside times the entire length. So outside times whole equals outside times whole. So it's always the outside piece times the entire length is equal to the outside piece times the entire length. And again, we just go one secant at a time. So if we look at an example here, as I look at this picture, they give me the outside lengths. What I don't have yet are the total lengths. So for R to Q, I have a 9 and 11, which I can put together, and that gives me my total length of 20. And then on the other secant line, I go from 10 to X, so I've got R to T is 10 and X, which would be X plus 10. I add the two pieces together. And so what we're going to do here is we're going to take outside 9 times the entire length 20, so that's my top secant line, is equal to, on the bottom I get 10 outside times entire length X plus 10. So it's outside times whole equals outside times whole. And so now when I go to solve this, 9 times 20 is 180. When I distribute my 10, I get 10x plus 100. And then if I subtract the 100 over, I get 80 is equal to 10x, which means x would equal 8. Okay, so outside times whole equals outside times whole. Same thing if we throw a tangent line in there. So now on this tangent line, what's interesting to note is that when I highlight the outside portion is also equal to the whole thing. And so we have a little bit different notation right here in this equation, and I want you to kind of ignore that for now because all we're doing is just what we did on the last one. I have an angle on the outside, so they're intersecting out here at point E. So I'm going to take the outside times the whole thing is equal to outside times the whole thing. So it's always outside times whole equals outside times whole. And so now if I look at an example with that, as we look at this picture here, so 10 is the outside portion, the whole length is also 10 because it's a tangent line. As I look at the other secant line, outside portion is 5, the whole length would be x plus 5. So I'm doing outside times whole equals outside times whole. And so for this example, I would take 10 times 10 is equal to 5 times x plus 5. Outside times the whole equals outside times the whole. And then I solve like normal. 100 is equal to, when I distribute, 5x plus 25. If I subtract 25 from both sides, we get 75 is equal to 5x. And if I take 75 divided by 5, x would equal 15. So on each of these problems here, if it's the inside, so as we're looking at the inside where they intersect, then it's just one piece times the other equals one piece times the other. If the segments go outside, so now we have secants and tangents, it's always outside times whole equals outside times whole. And then whatever that result is, you just solve it for what's missing. So with that, you should be able to start working through the worksheet that you get in class or off of Google Classroom. Make sure to ask questions in class. Make sure to check the answer key as it becomes available to kind of help you with any questions you may have.